Example, you want to have $5,000 in 4 years. For that, you put some amount of money in a special savings account, which pays a high interest of 6% per year. The bank transfers earned interest amounts to depositors every half a year. How much money do you have to deposit today? So the key word in the question is today, which tells you that we are interested in finding the present value, right? So now we are basically we are done with the main part of this chapter. We know what the future value is, we know what the present value is. And now I have a few examples where things are sort of mixed up. You need to figure out what needs to be found. Is it the present value or the future value? Look for a keyword. Read the text carefully and see how the question is phrased. Keywords for present value are, for example, today. How much you need to start with today. So what do you use for the future value? $5,000, which is given. What do you use for the interest rate R and for the number of time periods T in the formula? Well, you're going to use 3% for the interest rate and 8 for the number of time periods. Why don't you use 6% for the rate and 4 for the number of years? Because the bank transfers interest to you every half a year. This means that you wait not 1 year to see more money added to your account in interest, but only half a year, 6 months. And this is important because it actually makes a difference. Because after the first half a year, you have a little bit more. And then the total that you now have with that a little bit more money gets reinvested for another half a year. And so at the end of the full year, you will actually have a little bit more because of the interest on interest than how much you would have had if you had to wait a full year to get your interest. So it actually makes a difference. And to account for that, to do the calculations correctly, we need to reflect that frequency with which the interest is earned. So if the interest rate is 6% per year, then every half a year it's half of 6%. That's where 3% came from. And the money sits in the account and earns interest not 4 times, but 8 times, because it's twice every year. The answer we get is $3,947.05. Again, financial calculator. Where is it? Here. Turn it on. 5,000 is our goal, what we want to have in the future. Make it negative, press FV. We want to have it 4 years in the future, but we cannot put 4N because this way we will tell the calculator that the interest will be earned 4 times, which is wrong. It will be earned 8 times, 8N. Each time the interest is earned, how much is it? That's the real meaning of IY. Each time the interest is earned is half of the annual rate, 3%. So I put 3 IY. And finally, I tell the calculator to compute the present value. Compute PV, $3,947.05. And so it's important to read the question carefully. Read the words. What do the words tell you about how often the interest is earned? If you realize that the interest is earned semi-annually, then you need to use the semi-annual interest rate and the number of half years. If, for example, you realize that the interest is earned monthly, then you need to use the monthly rate, which is 1/12 of the annual rate that is given. And for the number of time periods, you need to convert everything into months. So whatever number of years you're given, multiply it by 12. If everything is daily, then you need to use the daily interest rate, for which you take the annual rate and divide by 365 days in a year. And for the number of time periods, you use days. And so if you're given a few years, you take the number of years and multiply by 365. That will tell you over how many days the daily interest is earned. So be consistent throughout your calculations. Example, your friend deposited $5,000 today at 8.5% interest for 5 years. You would like to have just as much money at the end of the next 5 years as your friend will have. However, you can only earn 7% interest. How much money must you deposit today if you are to have the same amount at the end of the 5th year? A lot of things going on here, right? Do we need to find the present value or the future value? First, let's summarize more visually what's happening. We have two people, your friend and yourself. Your friend deposits $5,000 today. His account pays him 8.5% interest rate per year. He waits 5 years. He will have some amount of money then. You want to have the same exact amount of money in 5 years in your account. The question is, how much should you deposit so that you also get the same future value? However, your bank pays you only a 7% rate. How would you solve a problem like this? You cannot do it in one step. You have to do it in 2 steps. Step 1, what is the future value of your friend? Then that becomes your future value, which you can then use to go back and solve for your required present value. Step 1, how much will your friend have? He will have $7,518.28. And we found that by taking his deposit, $5,000, and multiplying by 1 plus 8.5%, the sum raised to the power 5. And then your friend's future value becomes your future value, and you use it to find your deposit or the present value using the same number of years, 5 years, but a lower interest rate, 7% rather than 8.5%. So you take $7,518.28 and divide it by, open parenthesis, 1 plus 0.07, close parenthesis, power 5. The answer is you would need to deposit $5,360.43. Why does it make sense that you would need to deposit more? Because your money grows slower. You need to compensate for that. You'll compensate for the slower growth with a much larger deposit today. And eventually, you and your friend will be looking at equal future values. Again, let's quickly do this in the financial calculator. Step 1, your friend's future value, which will also be your future value. Your friend's present value, 5,000, negative present value. 5 years later, 5N, at 8.5% interest rate per year, 8.5 IY, what will be your friend's future value? How much will your friend have in his account after 5 years. Compute future value, 7,518.28. And then that becomes your future value. So actually, in this particular problem, we don't need to, clear and then start all over, kind of re-enter this number. You can immediately make it negative and press F5. It will work. 5 years for you, just like it was for your friend, 5N. Your rate is smaller, 7%, 7 IY. Compute your present value, $5,360.43. Right? So you would need to start with $360.43 more than your friend to make up for your money growing slower. Next example. What would you rather have? $4,000 in 8 years or $2,000 now? And you keep all your money in your high interest savings account that earns a 10% interest per year. This problem is kind of, it doesn't tell you clearly what you need to calculate. You need to pick, between the present value and the future value. You can solve it 2 different ways. You can either compare future values of the 2 options you're looking at, or you can instead compare their present values. So let's look at the first method. If you take $2,000 today, after 8 years, how much is it going to grow to? And if it's going to grow to more than $4,000, which is your second option, then you should accept $2,000 today. This is how we are going to approach it. So what is the future value of $2,000 after 8 years at 10% interest rate? We use the future value formula. $2,000 multiplied by, open parenthesis, 1 plus 0.1, close parenthesis, power 8. $4,287.18. And of course, you can always use the financial calculator, where you put $2,000 negative for PV, 8 is your N, 10 is your IY, compute FV. Because accepting $2,000 today will result in having more than $4,000 after 8 years, this is the option you should go with. Option number 1. Now let's look at an alternative solution. Probably a little bit less intuitive, although does the same trick. You instead compare the present values of the $2 amounts. Kind of the idea that this problem wants to illustrate is that when you have numbers at different points of time and you want to compare them, you should bring them to the same point of time. That's the point. So you cannot compare 2,000 and 4,000. You cannot say, oh, 4,000 is more than 2,000, so it's better. No. That's like apples and oranges. It should be 2 apples or 2 oranges, right? So let's make it all 2 oranges. What's the present value of $4,000? In other words, rather than waiting for 8 years, how much would you be equally happy with if you were given an equivalent of that today? The present value of $4,000 is $4,000 divided by 1 plus 0.1, the sum raised to the power 8. That gives $1,866.03. Same exact conclusion, because an equivalent of receiving $4,000 in 8 years is receiving $1,866.03 today. that's less than instead receiving $2,000 today. And so between the two options, you should prefer option number one, receiving $2,000 today. And so to summarize, it doesn't matter if you go with the future values being compared or with comparing the present values of the two options. It doesn't matter at all. Either way, you will come to exactly the same conclusion if you do the math right. Probably it's more intuitive to find the future value and then compare it with $4,000 rather than use the present value method, but they're both equally correct. So it's completely up to you. They are equivalent.